Hello everyone, my name is Manoj Reddy Chimala and I will be presenting about the recent ongoing trends in the automotive embedded systems. The motive is to provide a general survey of literature on the ongoing recent trends in the automotive embedded systems. A comprehensive review is conducted on these technologies and their methods, their procedures, especially spanning from early 1990s to the recent 2010s. If you look at the contents of the presentation, first I'll be giving a brief introduction and then we'll be talking about electronic control units, then multicore ECUs, then the communication and infotainment advancements, the power and energy management, and then lastly electrical and hybrid electrical vehicles. The demand for fuel efficiency and the reduction of emission controls, they all have propelled the automotive engineers to design for new vehicular technologies, and these are accomplished by the use of embedded systems. Embedded systems are everywhere in this modern world, and basically embedded systems are the combination of software and the real-time hardware. And when they are compared to general-purpose computers, they offer many advantages. Automotive technologies like automotive safety systems, engine control unit, adaptive cruise control, CAN, lane, they all require embedded units to be present in them. The first mass-produced hybrid electrical car, Toyota Prius. This has paved way for new revolution in the fields of electrical and hybrid electrical vehicles. Electrical control unit. It is also sometimes referred to as power control module or electronic control module. It is the brain of a car, and these are also termed as any energy management system because of their various functions and engine-related functions. AutoSAR is a notable international open industrial standard for designing and development of automotive embedded systems. It defines the standards and methodologies for automotive industries all over the world. Due to the complexities in the energy consumption and the manufacturing and packaging, single electronic control units are being replaced by multi-core electronic control units nowadays in the automotive embedded systems. A large number of innovative techniques have been developed in infotainment and communication areas. Intelligent traffic control systems are being developed for controlling and managing the traffic. The figure shows a typical in-vehicle embedded systems that are present in an automobile. Integrated embedded systems are also very helpful in preventive in controlling drunk and drive accidents by developing alcohol detection instruments. Most network which has developed exclusively for automotive multimedia applications and is also being in home environments because of its high-speed 3G, 4G networks and also low. Most offers high reliability, it is cost effective, and also recent advancements in embedded technology in most network has enabled the devices to support high bandwidth, better packet data sizes, and for more complex applications. Canvas can be seen in almost every vehicle nowadays. It was developed by Robert Bosch and it is a well-established technology providing interactions between various vehicles, sensors, actuators, and controllers. Canvas improves the vehicle's electrical system, it improves the information sharing system, it increases the robustness, it speeds up the data transferring, and it also increases the reliability of the automotive embedded system. Besides advantages, can also has some disadvantages because of like its limited network length and low security levels and causing troublesome in heavy traffic. Byte technology is developed by BMW company in 1996 for fulfilling the requirements of next generation automobiles, and it is heavily dependent on the FTDMA technique. Bytefed has some edge over the CAN technology, but it has to be a trade-off between the performance and flexibility. It combines the advantages of both synchronous and asynchronous protocol techniques. It increases data integrity and it is cost effective. Nowadays, in almost every smart car, we can see that CAN is being replaced by the Flexray because Flexray offers more high flexibility. It supports high data, and it also supports steer-by-wire and brake-by-wire applications. In one of the paper I reviewed, a simple flex system is fabricated with the help of Samsung 0.35 micrometer technology, in which altered Excalibur arm is integrated with the bus driver chip. M2M and V2V communication networks, which form ad hoc networks, they collect the information from various sources and they combine and take decisions on their own, and so in that process they help avoid potential accidents and crashes, and they're also in regulating traffic. In this picture, we can see how M2M and V2V technology is helpful in uh, avoiding potential crashes by the utilization of cameras and sensors and actuators which are located on the road. MTM utilizes the latest sensor technology combined with the internet in the cases like automatic crash notification, emergency services, and so it provides better data processing, passenger safety, and security management, etc. Uh, Vehicular ad hoc networks or VANETs is one of the numerous recent growing technologies. It has many benefits like it improving the efficiency of the traffic in managing and prediction of traffic and multimedia and infotainment applications and navigation and safety recognition operations, etc. Adaptive cruise control is one of the most popular embedded system technology which can be seen in every smart car today. It has been useful in controlling the speed of the vehicles and maneuvering the vehicle in heavy traffic and also maintaining the speed on highways. ACC helps in avoiding the accidents by using the better radar technology and controlling the car by the four modes like such as deceleration mode, acceleration mode, and the constant speed mode, as you can see in the pictures. Uh, if a vehicle is integrated with X-by-wire or steer-by-wire technologies, then it can significantly improve the ACC method. Uh, what X-by-wire method is, it replaces the vehicle's traditional physical controls of electronic control by electronic controls. Due to the rising fuel cost and rising greenhouse gases and also increasing pollution issues like global warming and global melting, there is a main focus on the energy management and battery efficiencies of the vehicles. There is a reason why ECUs are called energy management system because they control the energy efficiency, they monitor the idle spills, they supervise the engine functionings. Um, Electrical vehicles and hybrid electrical vehicles are the talk of the town in the automotive community. They offer many advantages by low pollution emissions and offering high fuel efficiencies. Uh, but they can also prove to be they also have many disadvantages like they are quite expensive and their hybrid vehicle can't run on long distances because it takes a lot of battery, and there are also ambiguous views on the battery lives and their life expectancy. For increasing the fuel efficiency and for better energy performance. There is a lot of emphasis on energy storage systems. A lot of different state-of-the-art technologies have been developed in the fields of electrical vehicles, hybrid electrical vehicles, uh, plug-in hybrid electrical vehicles, or fuel cell hybrid vehicles. A lot of different types of batteries have been developed. Lead-acid batteries, lithium-ion batteries, and uh, fuel cells have been proven very successful in by using them in hybrid electrical vehicles. As I said, modern powerful hybrid electric vehicles are they use Zebra batteries or lithium-ion batteries. And they are very cost effective and they offer high sustainability and they offer high efficiency. But in the case of sodium, in the case of lithium-ion batteries, they are quite expensive. And so for this, uh, the alternative is Zebra batteries are integrated with the ultra capacitors, thus, they increase the specific power density but they prove to be generating poor acceleration as well as poor regenerative braking. By concluding the presentation, we can see that there are many advancements in the automotive industries, many embedded system technologies in vehicle systems like adaptive cruise control, most M2M communication have improved tremendously improved the uh, comfort, engine's efficiency, and they also prove to be cost effective, and they provide safe and secure driving, and also the global warming, pollution, emission control, they have all propelled the uh, automotive industry to focus on the electrical vehicles and hybrid electrical vehicles. Clearly, some of these technologies have their own complexities and their own challenges, but let's hope that there will be many more improvements and advancements in these technologies in the future generations to come. Finally, I would like to thank my professor, Mr. Sudeep Prasija, for helping me in how to review the papers and letting me to know the format in how to write them. Uh, I also want to express my gratitude towards my friends Sakiran and Venkatesh Babu for their timely, invaluable advices. Here are the list of figures which I have used. This is a reference set. These are the papers which I have reviewed and which I conducted literature review on them. They all proved to be very effective and they all give some insights on what are the future generation technologies to come and what are the advantages and the challenges that is to be met by the present existing technologies. Um, Thank you very much for considering my presentation.